Okay. Yeah, so this is everything you guys did. You guys should be very proud of yourselves. This is like hard stuff. I hope you guys learned a lot and you guys had a little bit of fun at least. So you guys should be very proud of yourselves.
Hmm.
Um, okay. We're gonna start with this question, I think, right?
Yeah. This is probably like the easiest question out of the four
Yes,
you'll see.
yes.
Oh
Okay.
yeah, Sinchan, if you weren't I know you joined late, but basically today's the last day of class and we have four hard questions we're gonna cover, a book kit and a gem kit. So they decided they want to do the hard questions first. So it's gonna be like, yeah, go on.
Yeah, today is the last class, at least like in this. Uh, yeah, you can think of the homework says too, but like the homeworks were like kind of optional the entire time, so you didn't have to do them if you didn't want to. But we'd appreciate like the homework is just like for you guys like to review. So as
Hmm.
long as you guys like at least like thought about like the stuff you learned in class, that's good enough.
Hmm. So if you submit the homeworks today, we'll still grade it and give you feedback.
Oh no, the grades aren't sent to you guys' parents. It's okay. No, no, this is like a very low key thing. Yeah, yeah, of course.
Hmm. But yeah,
Okay.
this class is mainly based on attendance. So, we have like we're gonna have a system like later. We're not gonna explain it now, but there's gonna be a system with attendance, and then that'll like we'll send out emails for the attendance and everything.
Yes.
But go ahead and start doing the question. If you, yeah, if we're gonna let you guys struggle for 5 minutes, and then after 5 minutes, Um, if you guys still aren't getting anywhere, then we'll like whoever is not getting anywhere, just DM one of us or like yeah, DM one of us and then we'll give you a little hint. We're not gonna give you the answer, we're gonna give you a little hint to push you forward. Lucas is already giving you a bit. So go ahead. Go ahead and start.
We'll like regroup in like 5-ish minutes,
Hmm.
or if there are no answers, then we'll start giving out hints. But good luck.
Um, I know some people might be stuck, so and it's been 5 minutes, so I'm gonna like give a bit of a hint. So what Lucas did over here was he just gave you guys the general equation, right? You have to somehow twist this in order to fit this problem, correct?
There are two
So,
parts to this question.
mhm,
So you would be manipulating this equation in two different ways to solve this question.
you guys should list out what your variables are. So you know there's a horizontal, sorry, there's a horizontal distance. I'm gonna just say horizontal D, which is gonna stand for horizontal distance of 2.5, correct? There's also a vertical distance, or sorry, I should just say H. There's a height. There's a height of 1.2, right? So when you're using this equation, this V times T is going to be using the horizontal distance, but the one Lucas wrote up there is going to be using height. So what Lucas wanted to say was H is equal to VT plus 1/2 AT squared. Now, you guys can type in chat to everyone because we're discussing now. But do you guys know how we can kind of mold this equation or like how we can rewrite this equation? Because we're not going to be using this exact equation. We're going to be um, changing it in some way. Does anyone have a guess in chat? Just guess. It doesn't matter. You can private message your guess to us and we can check or anything. Because guessing's a really good way to learn because you might be right and like it'll actually stick, you know.
Think about what we know, like just from general knowledge, and also think
Mhm.
about what is not needed in this equation. Guessing a good
Um,
guessing is a good way if you don't know like where to start. Like you
mhm.
can explore like different paths to see if you're in the right
Yeah.
direction or not.
Because what guessing allows you to do is guessing is basically just thinking out loud, correct? And you're thinking out loud, like you can visualize a lot of different like options, like Lucas said, correct? So if one way is wrong, then you can just try a different way, correct? You don't have to be given the answer when you're guessing, right? You can guess and get it right because your thought, you know. Does anyone have a guess in chat? Like how we can change this height equation?
Think about what we could replace A with, maybe.
Yeah, what can we replace A with? What can we replace the acceleration with?
And this is only like worrying about our up and down motion right here.
Yes. And we're using the acceleration. So that's a good guess, but when we're
Horizontal
talking
distance
about
is what this H is. Oh no, horizontal
or
distance is actually not H, it's D.
yeah,
So we're looking for
the
like
height.
our height. Everything we're doing here is on the y-axis.
So, and I should probably explain why we're doing that first. We're trying to find this height because we're trying to solve for t. We're trying to solve for the time that is used in the horizontal distance equation, right? And we're doing this because we are given all the variables to solve for the t. So we can input it back, correct? So let's keep on guessing what the acceleration could be. Keep on throwing out things. What have we used for acceleration in past classes? Like there's a certain I don't want to give too much away, but there's a certain um what's it called? Certain thing we've used for acceleration. Everyone experiences it. Come on, guys. Keep on throwing out guesses. No, no one has a guess. Come on. Are you getting into DMs, Lucas?
No. Think about what is up and down and accelerates.
Hmm. Yeah. So we're trying to solve for t, but we can only solve for, sorry, t is equal to time, correct? Because like think about it logically, right? The object will travel how much ever distance it can before it fully hits the ground. Because once it hits the ground, we're taking it to stop, right? Height is also like in meters, correct? Acceleration is in meters per second squared. So what can we substitute for acceleration? So if we have, let's make this bigger. Vt plus 1/2 at squared. Velocity is meters per second, right? A
Neil is
could
right.
equal
Bing, bang,
gravity,
bang.
right? Those are good guesses, Sinchana. I like your effort. You were bound to hit it at some point if you kept on guessing. But A is equal to gravity, correct? Neil hit it.
Yeah. Neil beat you to the punch. Okay. If you think about this, gravity is the acceleration up and down. Will be the only thing like acting is the only accelerator up and down since there's nothing else, there's no air resistance on it. So whenever we're taking terms, whenever we're thinking about an object like flying through the air, it'll only be up and down. It'll like flying through the air, like up and down wise, the only acceleration will be gravity, like always, pretty much. So in this equation, it's actually just this, h equals vt plus 1/2 gt squared. And something to note here is we still can't solve this equation. We know what h is, we know what g is, but there's also a v here that there's still a v here that we don't know the value to. So we still can't solve it. But if you think about it, what does this v like actually represent? It represents like the starting velocity, the starting vertical velocity of the ball as soon as it rolls off the edge. So like, what do you guys think about that? You guys have any idea what this could be?
Think about it like, think about the equation that we're working with as only like a vertical equation, right? If we're pushing the ball horizontally, what could V0 equal? A number. It's going to be a number, right? So if we have horizontal motion,
uh V, like what we're looking for here, it's like when you push something off a table, like the exact instant it's not on the table anymore, what is its velocity? So like say like if you have anything on your desk right now, like if and you like pushed off your table, like think about like the moment right before it right before like right after it's off the table, what's the velocity of the object? Is it fast?
the
Is it
horiz
slow?
I just talking about velocity in general.
No, like the vertical velocity, because that's what we're looking for here.
Oh yes, then yeah. So what would the vertical velocity be if you're pushing an object off the table horizontally?
Yeah, so
Does
like
anyone have any
an
guesses?
object's here and it's sliding, 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 and like it falls right off. What is the like the instant it falls off? What is its how fast is it moving up and down?
Any guesses? Come on, guys, just guess. Guessing doesn't hurt. Only learning experiences.
Like four? It's not four. That's a good guess though. Oh, bang.
0. Okay, good
That's
guess,
correct.
Tanish. Okay, good guess, Tanish. You skipped 0, by the way, Tanish. No, no, no. Go backwards, backwards. Okay, never mind. But Ashreya is correct. It's gonna be 0, right? Because
Hmm.
this equation that we're using, I we probably clarified this a lot, but this is only for vertical. This is up and down motion, correct? If we're pushing a if we're pushing an object horizontally, then it doesn't have any up and down velocity, right? Sure, it's accelerating downwards by gravity, but we already have that component right here. So if like there's no vertical velocity on this object, so that therefore it's equal to zero. And if this is equal to zero, then this whole thing just gets erased out, right?
And
So
now
now
look
we know
what our
that,
equation
oh,
is.
yeah, it's just 1/2 h equals to 1/2 gt squared, right? And look at that, we can solve for time now because we know gravity is approximately 10 meters per second squared. And we know that the height is equal to 1.2 meters, right? So solving for t, you get square root of, what is 1.2 over 5? Point 0.2, square root of point 0.2. Is that what you got, Lucas?
Um,
So you get t is equal to 0.49 almost, right? Yeah. Yeah, Cinchana. You get 0.24 and then you have to square root 0.24 to get. Let's erase this. Let's erase this. Okay. This is actually not a bad equation. You don't need to memorize this, but it's not a bad equation to like get familiar with because a lot of the time, like just this equation just tells you how much time it takes for an object to hit the ground if you were given the height, correct? I could figure out how far my pet this oh you can't see because of my background. I can tell you how that or when this pencil with the will hit the table if we are given a height with this equation right here. And it will almost always be um probably plus or minus 1 meter or 1 second off, right? Somewhere in 1 second range, correct? So if we use this equation to find out when this ball hits the ground, you do, well, I'm gonna do all the algebra out so you guys don't get confused. And then once you do all the algebra, you get something like 0.49, right? And since we know this is the equation for the horizontal distance, we just need to find out what b is equal to, right? We know what x is. We know what x is equal to, and we know what t is equal to, right? You want to take it from here, Lucas?
oh, okay, yeah. So now we know what our time is. This time is how long the ball is in the air when it's falling. From the instant it rolls off the table, it takes like pretty much half a second to hit the ground. And so we know um it has some set we don't know. We don't know what the initial velocity is, but we know this equation, right? You guys are all familiar with this. V times t equals x or displacement, or like in this case, what, 2.5? 2.5. So this equation makes sense, right? Because velocity times time equals distance. Does everyone get velocity times time equals distance? Yeah. Okay. Okay. So even though the ball is traveling in this arc in the air, like horizontally wise, it's not the speed horizontally is not changing at all. It's traveling at some velocity it had when it left the table initially. So if we can find this velocity, no, if we know how long the ball is in the air or how long it's traveling, um, and we know the distance, we know what the initial velocity is because it's gonna follow this equation. So we can just plug it in. V0 times 0.495 equals 2.5. And this is this algebra's V0 equals 2.5. It's gonna be close to like 5 or something.
I think it is, yeah. It's somewhere around 5.
5.05. Yeah, that's 366. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6 meters per second. So boom, that's our answer. We know this ball, since it traveled 2.5 meters and it rolled off a height of 1.2 meters, we know initially it was traveling 5 meters per second. That's pretty cool, no? You guys get that? Are there any questions?
Isn't that crazy? You can figure out how to hit the bullseye if you just know the height and distance. There's literally the
Yeah,
only
that's
two things you need to know, and then you can figure out how to hit the bullseye, but by knowing how fast you just have to let go of the arrow or whatever.
how do you measure how
That's a good
fast you're
that's a
going?
good question. That's for you to figure out. No, it's basically just like I don't know actually. Do you know how you could do that?
Um,
You almost have to calibrate the system, right? Like you would have to have a speedometer and see how fast you throw objects to get it consistent, you know?
yeah, you just have to be super consistent.
Yeah. You have to like calibrate yourself to know how much. That's a good question. But that's besides the point.
Okay, we're done with part A here. That's pretty exciting. Should we work go into part B now?
Yeah, why not?
Okay, I'll get to it. Okay, bang. So, part B. If the marble leaves the table at twice the speed found in part A, how far from the edge of the table will it land? Okay, should I just start with it? Should I just go?
Yeah, do you guys want time or do you guys um well, do you guys want time or do you guys just want to go through it? Because I know some people solved both of them already, but I don't know if other people tried to do part B. Let's just go to part B.
Okay, okay. So if the marble leaves the table at twice the speed found in part A, so that's just 10.1 meters per second. How far from the edge of the table will it land? So like this kind of seems tricky, right? Because now we have a whole new speed here, but we have to remember that no matter how fast you're going, like horizontally wise up here, you're still gonna have the same amount of time in the air because there's still zero vertical initial velocity. We're still starting from zero and slowly accelerating over 1.2 meters vertically. So like no matter how fast we're going up here, we're gonna have the same amount of time in the air or travel time. So what was that before? Do you remember?
Hmm. It was like 0.495. We could probably use 5, but or point 0.5, but it doesn't matter.
I'll call it 0.5. So we spent 0.5 seconds in the air. And this is the same from the last problem. And we remember this equation, velocity times time equals distance. And now we have a new velocity, 10.1. We have the same time, 0.5. And this is gonna give us a new distance of like 5.05 meters.
Yeah.
That's how far out, almost double. So if you're traveling twice as fast up here, you're going to go pretty much twice as far down here.
Are we good? Is there any questions on this problem?
Okay, should we move on then?
Yeah.
Okay, question two. This one has to do with like kinetic and potential energy. I think this one's kind of fun.
Okay,
So,
oh, yeah. I'll write it out since it's easier for me.
okay. I'll read it out. There should be like about four of these, but some of them are more difficult. So if you guys don't want time to work on their own, we can just work through them as a group. So I'll start with this one. A 500-kilogram roller coaster car starts from rest at the top of a hill that is 25 meters above the bottom of a vertical loop. The loop has a radius of 8 meters and assume there's no friction or air resistance. Okay, so we were given mass initially. Mass of the car is 500. We know that the height initially is 25 meters up, and we know there's a loop that is, oh, this is not on a scale at all.
Yeah, that's what I was gonna say.
Okay, this loop in total from the top of the loop to the bottom of the loop is 16 meters. And we're looking for the speed of the roller coaster car at the bottom of the loop and the speed at the top of the loop. And what minimum height would the car need to start from so that it has a speed of at least 5 meters per second at the top of the loop? Yeah, got them, wrote out the things we should be focused on here, kinetic and potential energy equations.
H
So,
sub, oh, I should not, should I do H sub C? I just want to say height of roller coaster instead. I'm gonna say height H subs RC.
okay. Um, so I think this is a good start. We'll give you guys like 5 minutes or so to work on this question before we regroup.
Yeah. I don't think you guys need anything more. I think you can use everything that I've given to solve the question.
Oh, you guys should also know that it's a closed system and energy is conserved.
Yeah.
And that should be all you need pretty much. Okay, 5 minutes from now, we will regroup. Good luck.
Does anyone have any answers or questions? Lucas.
Okay, are
Oh
you
wait,
guys
can we? Oh
oh, are you guys feeling ready?
wait. Mm. If you guys submit answers, by the way, we're like we'll talk about it in like the thing. So you'll have to wait to see if your answer's correct.
Should we start
All right.
now?
Yeah, let's
Okay.
start.
Um, so a few things to note, like when you approach this question and you see that it's like a roller coaster, like usually roller coaster questions like this are always going to be like energy conversion questions. So we know initially we have 100% potential energy. So like if this is like at the start here, we have all potential energy. Like in the middle down here, we have like a mix of both kinetic and potential energy. At the bottom, we have all kinetic energy down here. And this loop is a conversion back from kinetic energy back into potential energy. But we know this loop doesn't go up to the max height up here. So this is still some potential energy plus some kinetic energy. And then back here, it goes down back to all kinetic energy. So looking at the stuff that they give us, we know we have everything we need to find all the potential energy up here. We know the mass of the roller coaster cart, we know the acceleration of gravity, and we know the height. So just straight up solving this gives us 500 times 10 times height of 25 of about 125,000 joules. Joules
I
is the
like the
correct thing
way
here, right?
Yeah. I like the way Lucas split this up into three different. I think this is something you guys can take away from like any problem that you do in physics. I like the way how Lucas split this up into three different components, right? He had a potential energy component, he had kinetic energy down here, and then he had potential energy plus kinetic energy, correct? I think we should if we gave this as a hint, I think a lot of you guys could probably solve it just by that because what ends up happening is if you see potential energy here, you can connect this immediately back to this, right? Like how I already did here. If you see all kinetic energy down there, you can connect that to this equation. And then if you see potential energy and kinetic energy here, then you can connect it and combine both of those, right? I think the way
Yes.
Lucas showed it, it makes it super duper easy to solve this problem.
Yes. Something to note is uh all energy is conserved here. So like our energy is just flowing back and forth from potential energy and kinetic energy is 100% conserved. So, okay, our first question is asking for the speed of the roller coaster at the bottom of the loop. And we know this bottom of the loop is like the bottom of the roller coaster at like a height of 0 meters, 0 meters. And whenever you see 0 meters, you just know that there's no potential energy there. It's all kinetic energy. So we know our 125, oops, sorry, I think I wrote where you're writing.
You can go.
125 of all potential energy is now turned into kinetic energy, which is all, yeah. Gotham has it here. So it's now equal to 1/2 mv squared. And we know the mass, so we can just plug and chug to find the velocity, which is what the question is asking for.
Hmm.
So our equation, do you want to write out the equation?
Yeah. Times two. What was the mass? 500
Oh, divide by
over
500.
500 equals V squared.
Yes,
What
this is all
is
we
that
need to
just
do.
5,000?
I have no idea.
500,000. Yeah, it should be 5,000. No, sorry, 10,000.
I got square root 500.
Did I do something? Oh, it's 250. It was okay. 500 is 5,000. Ooh, it's oh. Okay. Sorry guys, my math's kind of off today. Square because 250,000 divided by 500 is 500. That's
Yeah.
that's not me. That's
So
not me.
turned out just to be square root 500, and that is our answer to question A. That's 22. It's only two sig. Oh, yeah, it's only two sig figs. So 22 meters per second. Ta-da. That's part A completed. So let's clear up some space.
Do you guys understand? Does there any questions? I think you guys could get it by the fact that if we split up into potential energy at the top, uh, I think if you split up by the fact you see potential energy at the top and you see that potential energy is equals mgh, and then I think the main thing to know is when it's at the bottom, it just all gets converted into kinetic energy. If you know that, then
yes.
you can just solve for the velocity because then you just set the two equations equal and then do whatever, correct?
Yeah. Um, so this combination of potential energy and kinetic energy is what we're gonna use to solve like pretty much every part of this question here. So
Hmm.
I want us to ask him for the speed of the car at the top of the loop. We know at the top of the loop it's 16 meters off the ground, so it's gonna have some potential energy, like 16 meters worth of it, and it's gonna have some kinetic energy, which is what we're looking for, because kinetic energy has the like velocity component that we're looking for. So kinetic energy plus potential energy is going to equal the total energy, which at the beginning we know is 250,000, right?
125,000.
125,000, oopsies. Do you guys remember how we got this number here? 125,000.
That's just how much we started with the system, right? Because it
This is
starts
yeah,
from
this is how much energy is like to in the system, and we got it from the initial potential energy. Because here, right here, this potential energy value here, like let's call this PE1, is where all the energy in the system came from. A height of 25 meters, a mass of 500 kilograms, and we're on Earth. Okay. Yeah, 1/2 MV squared. Got it. So this doesn't turn into 1/2. Oopsies. Can you erase? Okay. 1/2 MV squared plus MGH is equal to 125,000. We know mass, we know gravity, and we know height, because this height is 16, because the
hmm
radius of the loop is 8 meters, and we can just solve for V squared. So this just turns into another plug and chug.
hmm I
Should
don't
I
have a
write like
calculator.
the, oh, should I
That
write like
is,
the,
I think we should rate. Does everyone, do you guys, can we erase? Because it's kind of getting messy. Oh, Lucas got it.
this is what our equation looks like right here. And we're just solving for V. And this is just a plug and chug, so it'll take a bit to do, but 500
5
times
times
10 times 16, 125, 123 minus this times 2 divided by 500 square root. Okay, I have, this is definitely wrong. Wait. Um,
Okay.
okay, this seems a lot more close to the correct answer. This is just going to turn into 13 meters per second. So the speed of the car at the top of the loop is 13 meters per second. Does everyone understand how we got that? So pretty much we know 125,000 is the total energy in this system here, and at the top of the loop there's a certain amount of potential energy and a certain amount of kinetic energy, and we know how much potential energy there is, so we can solve for how much kinetic energy there is, and we know the mass, and so we can solve for V because kinetic energy is 1/2 mv squared. Does everyone got that? Like put a thumbs up or let's say yes or something, and we can erase.
Any question? Oh, I know. Thumbs up, thumbs down. Nothing really. Oh, there we go. We got
Okay.
a thumbs up.
I'm gonna assume you guys got it, so I'll be erasing the
Yeah.
stuff here.
You can just do
Fatima, do you
delete
want?
all. Or do you want
Oh,
to keep some of the stuff?
I kind of want to keep some of the stuff, so yeah.
Okay. I'll help erase them.
Okay, part C. This one seems a little bit more tricky. So it's asking what minimum height would the car need to start from so that it has a speed of at least 5 meters per second at the top of the loop. So it's changing now. Now we don't actually know how much this height is anymore. It's asking us what's the minimum height. So at this point in time right here, the car has a velocity of 5 meters per second. So what height would this car have to start at? So when it goes through a loop-de-loop that has a radius of 8 meters, that at the very top it's traveling at least 5 meters per second. Okay, so at some at this loop-de-loop, there's kinetic energy and potential energy. And we know how much potential energy is at this loop because that's just mgh, which is going to be the mass of the car, 500 times gravity, which is 10 times the height of the loop, which is 16. So 500 times 10 times 16 equals 80,000 joules. 80,000 joules of potential energy at this point here. And then we can solve for how much kinetic energy is needed at this point because they give us the velocity it's asking for. So it'll be 1/2 mass, which is 500 times velocity squared. And the velocity that they're asking for is 5 meters per second. So it'll be 1/2 times mass of 500 times the velocity they're asking for, which is 5 meters per second squared. So times 25. And that's going to give us at least this portion right here is going to be 6,250 joules.
Yeah, we can do the other questions after if you guys want.
Yeah.
So, back to this, right? This whole thing is equal to the initial energy, right? Do you guys know what the initial energy is, right? The
Or just
initial
how
energy
much
is
total
technically,
energy there is.
yeah, which is technically the potential energy of the system, right? When you look at the initial energy, this is all potential energy, so it's just gonna be equal to mgh, correct? The initial height.
Yes. So adding these two numbers together just gives us 86250 in total energy. Um, so we're gonna be plugging this back into our potential energy equation, but now we're all potential energy. So this right here, this 86,250 is all the energy in the system. So when we want to find the minimum height the car starts at that point, it's all potential energy. So we're turning all this energy into potential energy. So it's just mgh equals 86,250. And we can just plug and chug here again. So this is just 86250 divided by the mass, which is 500, divided by gravity, which is 10. And that gives us 17.25. Height is 17.25 meters. Ta-da! Does everyone understand how we did that? To give like a recap, we took the minimum speed they gave us that the car had to have at the top of the loop. We turned that into kinetic energy, and then we added that to the potential energy we know the car would have at the top of the loop, and we turned that into the total. We set that equal to the total energy in the system, and then we went back to the start where it's all potential energy, and solved for the height needed to have that much potential energy from like, and that translates into height. So does everyone understand how we got that? Just put like a yes or it's like a thumbs up. Nice. Okay, okay. I think we move on to look at and game kits now. This is
Yeah.
hard stuff, guys. So
They didn't see the other two problems. Yeah.
yeah, I think we'll just go to the
That was
look
like,
at some game kits now.
yeah, that was like stuff we didn't even cover in class. So that'd been funny to watch you guys do.
Okay, so do you guys want to do the game kit or the look at first?
Yeah, you guys got to choose. Booklet has a bit harder questions than the game kit, but the booklet's also probably, I actually don't know. I don't know what kids like better, game kit or booklet. Game kit. I see two game kit.
Start with the game kit. Okay. I think I'll join you if we play. I want to play a game kit. I haven't played a game kit in a long time.
I'll share screen then.
I can still share a screen. I'm pretty sure in game kit you can like.
Well, that's okay. I'll share.
Okay, okay. Um,
But I also looked at all these questions beforehand, and I think you guys could do them.
yeah. Ba, 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 ba.
Sorry, guys. Give me a second.
Oh wow, they still make game kit battle passes. That's cool.
Play live. Oh, which one do you guys want to do? Knockback, Fishtopia, Don't Look Down, Capture. Oh my God, there's so many. What the heck?
Oh man, game kit really upped their game.
Wait, let me share a screen so you guys can see. Look at all this. They're saying don't look down, right? Okay, everyone said don't look down. I'm doing don't look down. Continue. 15 minute. How much time will this?
Oh yeah, 15 minutes should be fine.
Let's do 12, 13. When players fall. Do you guys want to checkpoints on? Yes, okay. Um, Energy per question. I think 1,000 is fine. We don't want to give you guys too much energy. I do 5K per question. Nice try, Denise.
Uh,
You're funny. Okay, join.
561 477. 561 477.
Should I join? Join
Sure.
as well. Do I press joining as a player or should I
Wait, yeah, I
just
think you're like defaulted to joining in.
really?
Like try moving around your
I can't.
mouse.
I can't. Oh, wait,
Oh,
I
there you
can't.
are.
What the heck?
That's pretty cool. So we are
Guys, this is
looking
a legendary
for
skin, by the way. I have a
oh
legendary
shoot.
skin. Oh, I should probably stop recording.